Chapter 6, Section 4, Functions, Master Video. In this video I'm going to introduce something called function notation. So a function can also be written using function notation. What is function notation? Well, since you're going to be working with functions quite a bit later on, and you may be working with more than one at the same time, well, you might want to have a nice way to tell them apart. It's just like we give people names to tell them apart. Otherwise, everyone would have the same name, and then giving them names would be kind of pointless. So here I have a relation. I know by looking at it, it is linear. And if I were to graph it, it would pass the vertical line test. So the name of the function right now is y, because that's the variable that's isolated. Well, I don't want to call it y. I want to call it something else. So I'm going to call it f for Fred. And I put an x here in brackets next to it, equals, and then I just copy what the expression on the right here is. So really the only thing that I did is I replaced y with f bracket x. Okay. This, how do we pronounce that? How do we read it out loud? We don't say fx. We don't say f times x. That's not what it means. We say f of x. In other words, it means that f is some function of x. In this case, it's 3x minus 4. Okay. So again, the name of the function is f. I could have chosen a different letter. And the independent variable is x. Okay, there it is. So we just list it here. So let's try a couple of examples. So it says, express the following functions using function notation. So right now I have a function. This is not linear, but y is isolated. I just want to call this something else. Let's call it Greg. So I'll say g of x equals 3x squared plus x minus 3. You may wonder by now, what's the point? Why can't I just call it y? Well, let's say I had both of these relations on the same graph. And I say, what's the y value when x is 2? Well, you're not going to know which relation I'm talking about. But if I name them and then I specify f or g, then you know automatically which function I'm talking about. Here, a equals pi r squared. I would hope you'd actually recognize this. This is actually the formula for the area inside a circle. Okay, but it's not written in function notation. Okay, so I am actually going to leave the a. But if I want it in function notation, I need to put this here. Because r, that is the independent variable. Pi is not a variable. That's a constant. So there we go. Okay, you don't have to use the letter A. You can use any letter you want. It makes sense to use A because we're talking about area. I don't know, you could call it J of r. R is the radius, is pi r squared. So really, you can choose any name you want. Okay, but it usually makes sense to pick a name or pick a letter that, well, makes sense. All right, let's talk about what it means to evaluate a function. Well, first of all, I'm just going to introduce you to, or explain what the notation means. I have two statements below. It says both statements below are equivalent, but which statement is easier to write? So I have a long sentence here written in English. It says, determine the y value when x is equal to 2. Okay, so I could be talking about this equation here, or this one. I haven't really specified. But it says I want x to be 2, so I would replace x with 2, and I'd work all this out, and I'd get my y value. That's what this sentence is asking me to do. Well, that's kind of a pain to write out, particularly if you have to do it many times. Well, I can actually say that same sentence writing only this much using function notation. That's one of the other benefits of using function notation, is that you can say so much more but actually write very little. So this says not f of x, but it says f of 2. So in this case, f, okay, I've replaced the x with the number 2. So what that tells the reader is I'm choosing x to be specifically the number 2. F of 2, therefore, is the y value that I get when I insert x is equal to 2. Okay, so again, both of these statements say the same thing, but this is sure a lot easier to write. Okay, so now below, I'm going to show you some examples of how it works. All right, so it says, given h of x equals 6x minus 5, determine the following values. Okay, so as you can see, I've used function notation here, but remember, this h of x, all that means is y. So I could have easily said y equals 6x minus 5. And you might think, well, that's just so much easier. Why can't I work with that? Well, if I wanted you to determine what's the y value when x is equal to 10, I would actually have to write out that entire sentence. Well, I can say that just as easily by just writing h of 10. Okay, it means the same thing. H of 10 means what is my y value when I choose x to be 10. Okay, so this is how you evaluate it. You should follow my steps, and then as I like to work down. So I'm replacing x with 10, so this becomes 6, and x is replaced with 10 minus 5, and I'm just going to work out what this is. So 6 times 10, of course, is 60, and 60 minus 5 is 55. Okay? So what that means is when x is 10, y is 55, or h of 10. Same thing. So as an ordered pair, let's say if I wanted to plot it, you don't have to write this down, but x would be 10 and y would be 55. So I could put a dot on a graph if I wanted to. Okay. Let's do another one. H of 0. Again, what does this mean? It means what is the y value when x is 0? Okay. I don't feel like writing that entire sentence out word for word when I can just say that exact same thing using function notation. This says h of 0. So it just means what is my y value when x is 0? So I just do 6 times x becomes 0. There we go. 6 times 0 is 0. Take away 5, I just get negative 5. So that's my y value. As an ordered pair, if I wanted to plot it, x would be 0, y would be negative 5. Okay. So again, this is just notation. Right? Let's do another one. What is h of negative 7? Okay. In other words, what's my y value when x is negative 7? Okay, so I just write out the function, and anywhere I see an x, I just replace it in brackets with that input. There we go. So 6 times negative 7, that is negative 42. Take away 5, that's negative 47. So an ordered pair, x would be negative 7. That's what goes in. And what comes out is negative 47. All right, the next one's a little bit different, so let's just read it carefully. It says, determine the following values. It says, what is x when h of x is negative 17? Okay, don't be frightened. Remember, what does h of x really mean? It's just y. So what this says is, if my y value is negative 17, what does my x value have to be? Okay, we're going to have to do a little bit of algebra, because y, or h of x, that's the one that's isolated. But in this case, it's x. That's what we want. Okay? So I'll show you all the steps so everything's nice and clear. So I'll write out the entire function again. Why not? You don't have to do this part, but I want to be perfectly clear. So this is my function using function notation. That's just y. But I'm told that this entire thing, this y, is negative 17. So I'm going to replace that with negative 17. Because I haven't told you what x is. So I leave it as x. So this is now a very basic equation you could easily solve. So let's solve. Let's isolate. What you do to one side, you must do to the other. So let's add 5 to both sides. So negative 17 plus 5 is negative 12. Okay, and that just leaves me with 6x on that side. So that's better. So finally, to isolate, I can divide both sides by 6. And those cancel. Okay, keeping everything lined up. So that just gives me x is equal to, and negative 12 divided by 6 is negative 2. So I just worked backwards. I gave you the y value first, and I just worked backwards to find the x value. So the ordered pair, if I wanted to plot this point, x would be negative 2, and y would be negative 17. All right? All right, it says, given r of x is equal to 9 minus x, which robot diagram, or diagrams, illustrates the correct output? Okay, so I chose R for robot. Okay, remember, R of x is just another way of saying y. So this is just like y equals 9 minus x. Okay, so here we have our machine. This is the function, and what goes in is the number 0, and it does its thing. And then at the end, it spits out the number negative 2. So we want to see, do these numbers fit this function? So let's test it. Okay, that's what goes in. So that's the x value. So that means we're trying to figure out r of 0, meaning what's the output value? So that is 9 minus, and that becomes 0. That, of course, is 9. So according to my function, if 0 goes in as the input, the output should be 9. But it's not. Okay? It gives me a different output. Okay? So clearly this diagram does not illustrate this particular function. Okay? So bad robot. Let's try the next one. So we put in the input, that's our x value. So if 6 goes in, for this robot 3 comes out. So let's see if that matches our robot function here. A little tight on space, I'll squeeze it in here. So we're trying to determine r of 6. And we're going to compare it to what the robot actually gives us, what this one does. So this is 9 minus x, but x is 6. 9 minus 6 is 3. And that's the output that it gives us. So, good robot. All right. Now it didn't say that there's only one, so let's test them all. So, negative 1, that's our x value. 10 comes out. So let's test it with our function and see if it's the correct robot. So this is r of negative 1. And that is 9 minus x. So I have to be careful. 9 minus negative 1. Okay? 9 minus negative 1. That is the same as 9 plus 1. Which is easier to understand. Of course, it's 10. And that's what this robot gives us. So both of these robots work correctly. So there's the only bad robot.